Hey guys, so this is lesson number 91. So we're going to continue with finding the area between two curves. Today's going to be a little harder though. This is probably, I would say, one of the harder lessons with this in this area. I'm going to skip the do now. Alright, so here's why it's difficult. We're going to find the area enclosed by the graph of f of y and g of y, right? So instead of having the functions in terms of x and y, we're going to be in terms of x, they're going to be in terms of y. So let's think about the graph for a second. If we have our graph, right? So before we had the top minus the bottom. So here's my, let's call this my, one of those. And here's my other function. And we're going from C to D. So now this is the area. Right? So this is my C. This is my D. Now here's the question. Which one is going to be F, the blue or the red? Just like yesterday, it was big minus small. So what has a what's greater when it's like this? So the blue is our F. Oops, make that blue. So when you have it in terms of y's, you're going to do right minus left. So that's something to keep in mind. When we're doing things in terms of y, this is the distance that we're finding. Instead of up and down, it's left and right. And it's right minus left, just like the top minus bottom before, right minus left. Okay, so now this is in terms of x's. So I'm going to show you this. We're going to do this problem as review, and then we're going to jump into some y's. All right, so now this one's a little tricky because we need to know what these look like. So hopefully you know what a square root looks like. So this square root, g of x, we'll start with that one because that's the easier one. It's shifted to the right 4. And because the x is negative, it's going to the left. And then look at the second one. So here's what I did to graph the second one. 4 minus 4x. What I did was I factored out that 4, so square root of 4, square root of 1 minus x. So it's 2 1 minus x. So this one touches at 1. And then where do these intersect? Now, if you plug in 0 into g, you get 2. So this is 2. But if you plug in 0 into the other one, you also get 2. So this is what this graph looks like. Now, how are we going to find the integral of this, the area between the curves? Now, this is why y's are good. We're going to do this in terms of x's because it's really annoying to do in terms of x's. The problem is because it changes top minus bottom, right? Over here between 0 and 1, my black graph is on top. The 4 minus x is on top. And then my square root of 4 minus 4x is on the bottom. So we would have to do 0 to 1, 4 minus x, minus 4 minus 4x dx. And then add to that just the black graph, the 4 minus square root of 4 minus x. So we have to break these into 2 pieces, which is super annoying, right? So instead, we want to do this in terms of y, right? In terms of y is significantly easier. So to do this in terms of y, I'm going to take my 2 graphs and I'm going to solve for y. So for my, let's do g real quick. Sorry, this slide is going to be terrifying. So y equals the square root of 4 minus x. So we get y squared equals 4 minus x. x equals 4 minus y squared. And then, so we have this one. And then do the same thing for this guy, and we get y squared equals 4 minus 4x. 4x equals 4 minus y squared. X equals 1 minus 1/4 y squared. So now here's the nice thing. If we do this in terms of y, what's our right function? Right? It's right minus left. So the right function is my black function. So that was the 4 minus x, which is 4 minus y squared. Okay, make that a y. Minus my red function, which is 1 minus 1/4 y squared dy. Now what's my smallest y value? 0. And the biggest y value is 2. So because we can do right minus left without a problem, right? It doesn't matter where I draw this region, it's always going to work. So setting it up in terms of y is significantly easier. So we can, let's simplify this a little bit. So 0 to 2, let's see, we've got negative y squared and positive 1/4 y squared. So negative 3 over 4y squared. And then 4 minus 1 is 3. And even like we got rid of the fractions too, so it just makes this so much easier. All right, I'm going to try to fit this in. So we've got y cubed, so negative 1/4 y cubed plus 3y from 0 to 2. Let's see, negative 8 over 4, so negative 2. And then we plug in the 2, so plus 6. Okay, helps if I put my pen back on. Plus 6. And then when we plug the 0 in, it's just 0. So we end up with 4. So I did do this in terms of the radicals, and you get 4, but it's significantly more work. So this is why, in terms of y, is very, very helpful, so that we don't have to break this up into multiple integrals. All right. Find the area, A, of the region enclosed by the graphs of f of y equals y plus 2 and g of y equals y squared. So think about what this graph looks like, and that's the hard part. We never really spend a lot of time graphing these, so a lot of students don't know what these look like. So if you're not sure, I've got x equals y plus 2. So just to get a good idea about the graph, all right, so this first one is just x minus 2. So x minus 2. And then we have x equals y squared. Now, x equals y squared is the square root of x. But because remember, y squared is not a function. So this graph, we'll do green. It's not just the square root, it's both sides of it. So this here is the region that we care about. So because it's plus or minus. All right, so now we need to figure out what are our bounds. What is this point, this y value down here? What's this y value up there? We set them equal. So it's the same process as before. Y squared minus y minus 2 equals 0. So y minus 2, y plus 1. So our bounds are negative 1 and 2. So it's the integral from negative 1 to 2. Now it's right minus left. The blue graph is on the right. I did not make the colors the same as the graph. So the line is on the right. So that's our y plus 2. Minus the left function is the green, the parabola, our sideways parabola. dy. Find the antiderivative. So we get y squared over 2 plus 2y minus y cubed over 3 from -1 to 2. Plug in. 2 squared over 2 is 2. 2 times 2 is 4. 2 to the third is 8, so 8 over 3 minus parentheses or brackets 1/2 minus 2 plus 1/3. All right, so let's do some math on our brains. So I've got 2, 4, and then a positive 2 because I have the -2 and the negative and -2 is 2, so that's 8. And then we have the -8/3 and minus, so that's -3 minus 1/2. So that's 5 minus 1/2 is 4.5. All right, so 4.5 or 9 over 2, whatever you prefer. And that's it. So same process, just keep in mind right minus left. Pause the video and see if you can figure this one out on your own. So I'm going to draw my graph. So notice the second equation is actually in terms of y. Okay. So what does that look like? That goes up to 8, and it's got a negative slope, so that's my graph for that one. And then if you're not sure what this looks like, because you don't know what y squared plus 6, like does that go right 6, left 6, what's happening? I'll just quickly solve. So y squared equals x minus 6. So it's the square root of x minus 6 plus or minus. So that means I'm going right 6. So say here's 6. And it's just it's a square root, but then it's going to have that bottom piece too. So think about, would this be better to do in terms of x or in terms of y? Well, if we do in terms of x, remember that's up and down. So I would have to do like the top blue minus the bottom blue, and then the red minus the bottom blue. That would be obnoxious, right? So we really, really, really don't want to do that. And this is why we learn this topic, because there are certain functions that are significantly easier to deal with when it's in terms of y. So if we draw like the distance from here, it's a lot easier to do, right? Instead of going up and down, left and right, I just have to do red minus blue. So we need to find where these are equal to each other. So I need to take my line and solve for x. So x equals 8 minus y. Set them equal to each other. So the original y squared plus 6 equals 8 minus y. Y squared plus y minus 2. Didn't we just do this equation? Y plus 2, y minus 1. So our bounds are -2 and 1. So the integral from -2 to 1, right minus left. 8 minus y minus parentheses y squared plus 6. I'm going to rewrite that to make it a little nicer. -2 to 1. We got 2 minus y squared. Antiderivative 2y minus y squared over 2 minus y cubed over 3. We will be doing these on the calculator, but right now I really want to focus on doing these by hand. Plug in 1, I get 2 minus 1/2 minus 1/3 minus bracket -4 minus 2 plus 8/3. You notice that 8/3 comes up so often? Kind of annoying, huh? All right, so let's see what I have for whole numbers. I've got my 2, I've got a positive 4 and a positive 2. So that gives me an 8. Minus a half. And then the 3, the one with the third, so that's minus 3. Didn't we just do this exact problem? 5 minus 1/2 equals 4 1/2. This is literally, that ended up exactly like that last problem. How did I not realize that when I did these earlier? That's so funny. All right, next one. All right, so now we're going to do an AP problem. I want you to pause the video. You need to find this point. This is a calculator problem. So pause the video, put y equals tan x, y equals 2 minus x cubed into your graphing calculator, and find that point. All right, so if you do that, I got 0.902155, and I called that A in my graphing calculator, 1.2657. And I called that B in my graphing calculator. All right, now looking at these two graphs, should we do them in terms of x or in terms of y for each of them? So let's look at R first. So for part A, R, do we want to go up and down or right and left? Now if I try to go up and down, I'm going to have two integrals. Something to 0.902 and then 9.02 until whatever that point is. Yeah, we also have to find where that equals. So if you're going to do this in terms of x, you need where 2 minus x cubed equals 0. So, is it easier to do it that way? No, of course not. We're going to erase that. We don't want to do that. That's dumb. Why do more work than I have to? If I do right and left, I can just do one integral. And I already found the y value. It's going from 0 to a. Now, we need this right function. This is my right function. We need it in terms of x's, though. So if I have y equals 2 minus x cubed, I meant in terms of y. So that's x cubed equals 2 minus y. So we get the cubed root of 2 minus y. Minus our left function. The left function is the tan. Tan is just, so it's just arctan, right? So tan minus 1 of y. And because this is a calculator question, we're just going to plug that in the calculator. And I get 1.226. Done. All right, B. Now for B, we have region S. So should we go left and right or up and down? Now this one you want to go up and down, right? Because we have top minus bottom, left and right, we would have to do the blue and then the black separately, the tan separately, and then the 2 minus x cubed. So this one we want to do in terms of x's. We do need, though, that if we're going to do top minus bottom, 0 to what? What is that point? Oh no, I wrote it wrong in the other problem. Let's go back real, you probably are yelling at the paper. We needed a y value there. This was a b. I did it right on the paper. I'm pretty sure that's the right answer. So for this one, we're using our x values this time. So 0 to a. So it's nice that I found those. Top 2 minus x cubed minus the bottom, tan of x. And then again, this is just a calculator problem. All right, so I plugged in the calculator and I got 1.161. And I just redid the bottom one and got a different answer. So I'm not really sure what I did the first time, but I just got 0.729. So if you have a different answer than mine, I don't know what I did. I'm not sure which is correct. I'd have to look that up. So, I don't know. If you got 0.729, that might be the right answer. I have to look through my work. I'll look at that later and let you guys know. All right, I think that's it. Here is your next homework. We are going to spend one more day, I think, on the area with left to right. And really, we're going to really be focusing on those AP problems. So we're going to really get in the calculator tomorrow. All right, so let's see. Who should we draw? I don't think Autumn was ever in any of the pictures. So let's say, here's her ponytail. All right, so there's Autumn. And she's happy because she loves AP Math. All right, 5. Autumn. Yay, we're amazing. We're all going to get 5s. All right, have a great day, guys.